scholars, and welcome back to Peak Flicks Math. I am so excited to see you today because we always have a great day of teaching and learning. And are you ready for another great day of Peak Flicks Math with Mrs. Dennis? Oh, stop it. I know you are. So let's dive into lesson 11 of Peak Flicks Math. So, remember our last lesson, we started learning about fractions. So today we're going to continue learning more about fractions. And we're going to use our favorite foods, slices of pizza, to help us understand fractions. So let's look at our objective for today. It says I can partition a whole into equal parts and define the equal parts to identify the fraction numerically. Whoa, that's a very wordy. So let's kind of go dive in and see what the objective is really asking us to do. So I can partition. Well, when I see that word partition, I recognize the word part. So I know my objective today is going to deal with parting a whole into equal parts to define the fractional part. So what is that word partition? Well, partition just means when you take a whole and you split it into equal parts. So today our goal is going to be to take a whole and break it into equal parts. But before we get into our objective for today, let's build our fact fluency. Woohoo! Because when we are fluent in our math facts, it makes us what? Absolutely better mathematicians. So let's review our fact fluency in multiplication. Today, guess what? I have a really good treat for you because I'm going to show you a strategy to help you with your 7 times tables. So, do you have your notebook? Great. Do you have a pencil? Great. Or do you have your whiteboard? Okay, great. Do you have your marker, your dry erase marker? Great. So Miss Dennis is going to show you a strategy to help you with your 7 times tables, okay? And it's called Tic Tac Toe with sevens. How many of us have ever played Tic Tac Toe? Okay, great. And guess what? If you haven't, that's fine because we're going to use this strategy today to help us learn our 7 times tables. So this is what I would like for you to do in your notebook or on your whiteboard. I want you to first draw a line up and down in your notebook or your whiteboard. And then you're going to leave some space and you're going to draw another line because we gotta have to set it up like tic-tac-toe, right? Okay, great. So now what I would like for you to do is I want you to now draw a line that goes across those 2 lines. And then you're going to draw another line that goes across those other lines. So in your notebook or on your whiteboard, it should look just like this because it's kind of like tic-tac-toe. And we have to first set it up. So this is going to really help us with our 7 times tables. So thumbs up if you have this in your notebook. Good? Okay, great. Now, this is what I would like for you to do. You're going to go on the far side. You're going to write 0, 1, and 2. And I want you to leave a little bit of room because there's some other numbers that's going to go in there. Because remember, this is helping us with our 7 times tables, okay? Just keep that in mind. After you do 0 through 2, 0, 1, 2, I then want you to write in the next column 2, 3, 4, just like that. Okay? Are you done? Okay, great. Now I want you to go to the last column and you're going to write 4, 5, 6, just like that. So now in your notebook you should have 0, 1, 2, 2, 3, 4, or 4, 5, 6. And this could be done in your notebook or in your whiteboard, whatever you have next to you or in front of you, okay? So now, after we write these numbers, and remember, Miss Dennis wanted you to leave a little bit of room, we're now going to start at the bottom row. And we're going to start in the very first column. And I want you to write 1, 2, 3. Just like that. You're good? Okay, great. Now I want you to write 4, 5, 6. You're starting to see a small pattern here, right? Okay, great. So did you write 4, 5, 6? So 4 goes next to the 1, 5 goes next to the 3, and 6 goes next to the 5. We're good? Okay, great. Now I want you to go to the very top and you're going to write 7, 8, 9. Just like that. And guess what, scholars? This is our 7 times tables. Can you see it? Okay, well, let me help you see it. Ready? So this is 7 times 1 because it's in the very first box. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is, you got it, 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. Can you see the 42 there? Great. 7 times 7 is 49. 7 times 8 is 56. And 7 times 9 is 63. And right there, my scholars, you have your 7 times tables. So from now on, we can use Tic Tac Toe to help us with our 7 times tables. And this will help us with our fluency. So now that you have this in your notebook, I'm going to test you out. As you know, Miss Dennis is all about us after we knowing our facts, we have to practice. So we're going to practice together. But this time, you see, normally I give you 15 seconds. But this time, because you should have this in front of you, we are now going to have 10 seconds to solve the next few problems. Are you ready? Oh, you can do better than that. Are you ready? Great. I'm so excited. So get ready because now you have 10 seconds to solve the next few problems that's going to deal with our 7 times tables. Are you ready? Okay. So let's try the first one. I'm just going to move myself over, make myself a little smaller. So let's try the first one. What is 7 times 2? Miss Dennis will give you 10 seconds, okay? Ready? Go. What is 7 times 2? Great. Okay, time's up. 7 times 2 is 14. You got it. 7 times 2 is 14. And when you look inside your Tic Tac Toe, it's very important that you look at the second box in the first row because that'll tell you what 7 times 2 is. Great. You ready for another one? Okay. Here we go. 10 seconds. What is 7 times 4? Go. Okay, time's up. 7 times 4 is, you got it. 7 times 4 is 28. And if we look at our Tic Tac Toe, you can count 1, 2, 3, 4. It will be the second box in the first row. So 7 times 4 is 28. Let's try another one. Ready? 7 times 6, 10 seconds. Are you ready? Set, go. Okay, great. Time's up. 7 times 6 is 42. You got it. And remember, it would be the last answer in the second column, in the second box. So we know that 7 times 6 is 42. Let's try one more. 7 times 8. Are you ready? Set, go. Okay, time's up. 7 times 8 is 56. Great job. And we are going to look in the last column of our box and we check the second row because 7 times 8 is 56. Isn't math so much fun? Oh my goodness, I love it. And every time we learn these little strategies and tricks, it only helps us become more fluent in our math facts. So now that we've practiced our fluency, are you ready to dive into our objective for today? Great. Let's go back and look at our objective. So we know that today our objective is I can partition a whole into equal parts and define the equal parts to identify the fraction numerically. And we talked about how that word partition, right? We hear that word partition, right? So when you partition something, that means you take a whole and you just split it into equal parts. Okay, so our goal for today is to take a whole and split it up into equal parts in order for us to get our fraction. So let's just do a little review because I know what you're thinking. Well, Miss Dennis, what is a fraction? Well, a fraction is just a part of a whole. Say it with me. Ready? A fraction is a part of a whole. One more time. A fraction is a part of a whole. Excellent. And when you remember that, that will help you when you have to find the fractional piece of your whole number. So let's just look, and Miss Dennis is going to move herself over a bit just so we can really look at our chart. So here we go. So remember that a fraction is an equal part. That's very important because all of the parts have to be equal. So a fraction shows an equal part of a whole. And we talked about, right, remember that this top number here is called the numerator. Can you say numerator? Excellent, numerator. And the numerator is the number of the part that is counted or shaded. And normally the numerator goes at the top of our fraction. And then we also have this bottom number, which is the denominator. Can you say denominator? Great, denominator. And so the denominator is usually the number of pieces that make the whole. And so a fraction is just part of a whole. Say it with me. Part of a whole. Part of a whole. Okay, we can stop. So usually a fraction is a part of a whole. And fractions, you'll either see the numerical number, right? 1/2. And then you will see the written number 1/2. So 1/2 is the same thing as 1/2. 1/4, right? The part of the whole is the same thing as 1/4. So this is written and this is normally the number, right? And it's very important to remember that fractions are just equal parts of a whole. So let's practice. Now that we know what a fraction is and we talked about the numerator and the denominator, let's just now go into practicing how to part a whole, right? Partition a whole into a fractional part. So if we have to look at our pizza here, yum, yum, how many parts of the pizza make up the whole pizza? Let's count together. Are you ready? Okay, good. 1, 2, 3, 4, 5, 6, 7, 8. Excellent. There are 8 parts that make up this whole pizza. And so my denominator is going to be 8 because 8 represents the whole pizza. But let's say we got hungry. Man, I'm hungry. And we eat 1 slice of pizza. So then how many slices of pizza did we eat? Well, if we ate 1 slice of pizza, then and Miss Dennis is going to move over to you just so you can see, then our numerator would be 1. And so we ate 1/8 of the pizza because we ate 1 part out of 8 whole slices of pizza. Okay? Great, let's try another one. So let's look at our new pizza. Well, how many parts make up the whole pizza? Let's count together. 1, 2, 3, 4, 5, 6, 7, 8. Great. 8 parts make up the whole pizza. And so we know our denominator or our bottom number is going to be 8. So let's say we got hungry again. Oh my goodness, I'm hungry. And we ate not one, but two slices of pizza. What would be our numerator? Well, how many parts of the pizza did we eat? Excellent. We ate two parts or two slices of pizza. And so then our numerator would be 2 over 8 because we ate two parts out of 8 parts or 8 slices of pizza. Let's try another one together. Now let's look at our new pizza. What happens if we count the number of parts of the whole pizza? Let's do that together. Ready? 1, 2, 3, 4, 5, 6, 7, 8. So, this number 8, is it going to go at the top or is it going to go to the bottom? Excellent. It's going to go at the bottom because the bottom represents the whole number of slices we have all together to make the whole. Excellent. So now let's say we got hungry again and we ate 1, 2, 3 slices of pizza. What number are we going to put in our numerator? Well, I know I ate 1, 2, 3 slices. So I ate 3 parts of a whole pizza, which has 8 total. So my fraction is going to be 3/8. Let's try another one. So let's count how many parts make up our whole. You ready? 1, 2, 3, 4, 5, 6, 7, 8. 8 again. And this time 8 is going to go in our, you got it stays the same. It's going to go in our denominator because the 8 parts make up the whole pizza. So now let's say we got hungry again. Oh my goodness, I'm so hungry. And we ate 1, 2, 3, 4, 5 slices of pizza. How much of the pizza did we eat? What would be the fraction? Excellent. Our fraction would be 5/8 because we ate 5 slices of a whole pizza. Let's try one more together. I think you got the hang of this by now, but let's just keep going just to see. So now, how many parts make up the whole pizza? Let's count together. You ready? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts make up the whole pizza. So we know our denominator is going to be 8 because that makes up the whole. What happens if we get hungry again? Oh man, I'm so hungry. And we eat 1, 2, 3, 4, 5, 6, 7. Now we ate 8 slices of pizza. What would be our numerator? Excellent. 8, because we ate 8 parts of a whole pizza, which means if you look, there's no more pizza left. So we ate the whole pizza. So when you have the same number in the numerator and the same number in the denominator, you have one whole. We ate the whole pizza, so there's nothing left. So our fraction is 8/8, which is the same thing as one whole. Great job, scholars. So now let's practice using a word problem. And I want you to remember our objective. I can partition a whole into equal parts and define the equal parts to identify the fraction numerically. Excellent job. So now let's practice with our word problem. Are you ready? Okay, great. So it says Avanti has a book with 6 chapters. So in the whole book, she has 6 chapters. We got that so far, right? Okay, great. She read 1 chapter of her book. What fraction of the book did she read? I'm going to read that one more time. Because remember, when we read a word problem, it's very important that we go back and we find the numbers, we find those keywords, and we also try to figure out what is the question asking us to do. So Avanti has a book with 6 chapters. So in her whole book, she has 6 chapters. And she reads 1 chapter of her book. What fraction of the book did she read? So let's think about the amount she read. Well, let's think. How many chapters are in the whole book? Excellent. There are 6 chapters in the whole book. So we know that the denominator or the bottom number is going to be 6 because that 6 represents the whole book. Now, if I go back in my problem, it says she read 1 chapter of her book. So what fraction did she read? Well, if she read 1 chapter, then she read 1 part of the whole book. So my fraction would be 1/6 because she read 1 chapter out of 6 chapters total. So now, it is also asking us, well, what is the amount that she did not read? So now we have to think, well, how much of the book she did not read? Well, I know that total there are 6 chapters. So my denominator is going to stay the same because that number represents the whole. There's still 6 chapters of this book. So the denominator is going to be 6. Now, I know that the problem is telling me that she read 1 chapter. I know that Avanti read 1 out of 6. So now I have to think, well, how much of her book did she have left? So if I know the whole is 6 and she read 1, I need to find out, well, how many chapters does she still need to read? So I need to find out from 1, what number plus 1 will give me 6? So let's think. We have 1, 2, 3, 4, 5, 6. 5. So I know that 5/6 is the fraction of the chapters she did not get to read left. Because when she reads the entire book, she will have 6 out of 6 chapters read. Excellent job, scholars. Isn't a picture worth 1,000 words? And when we look at our fractional pictures, it really helps us to kind of see the whole and the fractions. So now it's your turn. I want you to try to read this word problem and work on it inside of your notebook or on your whiteboard. But first, let's read the problem together. It says Chloe's dad divides his garden into 4 equal sections to plant tomatoes, carrots, peppers, and cucumbers. What fraction of the garden is available for growing tomatoes? I want you to pause the video here and come back as soon as you can. So think about what fraction of the garden is available for growing tomatoes. And this is what I would like for you to do in your notebook. You're going to think about, well, how many parts is his garden divided into? Of those parts, how many parts are for tomatoes? And then you're going to tell me the fraction of the garden that is for growing tomatoes. So, right now, I want you to pause the video here. And when you come back, we are going to check our work because Ms. Dennis is going to show you the answer so you can check your work. So remember, you are telling me, well, how many parts are in his garden? What fraction is he growing tomatoes? And how many parts are just for tomatoes? So pause the video here so you can practice this in your notebook. And when you come back, we are going to check our work together. Okay, scholars, get to work. I'll be right here when you come back. Okay, welcome back. I hope that you really took that time to write the fraction of the garden that's growing tomatoes. So now let's check our work together. So let's refresh our memory of the problem. Remember, Chloe's dad divides his garden into 4 equal sections, right? And if we look here, there's 1, 2, 3, 4 sections that make up the whole garden. And he has tomatoes, carrots, peppers, and cucumbers. And we would like to know, well, what fraction of the garden is available for growing tomatoes? So, how many parts of his garden, how many parts is his garden divided into? Well, if we look at his garden, let's count how many parts are there. There are 1, 2, 3, 4 parts of his garden, or 4 sections. So we know that there are 4 parts of the garden. Of those 4 parts, how many parts are for tomatoes? Well, if I had to look at my picture, I notice that 1 out of the 4 parts are for tomatoes. And so I know that 1 out of 4 parts are for tomatoes because this part is for carrots, this is for peppers, and this is for cucumbers. So if I had to write my fraction of the garden that is for growing tomatoes, well, I know that there are 4 parts total that make up the whole, and so my denominator is going to be 4. Now, out of those 4 parts, 1 part is for growing tomatoes. So what fraction of the garden is for growing tomatoes? Well, 1/4 of the garden is for growing tomatoes. Now, I want you to practice some more. Miss Dennis is going to quickly pause the video here, and I want you to continue practicing your fractions in your notebook. Now, I want you to look very carefully. Each strip represents one whole. So this strip is one whole, and you notice there's like a small line to separate the other strip here, which represents one whole. And I want you to label the shaded and the unshaded parts with a fraction. So I want you to tell me, well, what fraction is shaded? And you can look at this little bracket here to help you. And I want you to tell me what part is unshaded. And I want you to do that for both wholes, okay? So I want you to pause the video here again. And I want you to look very carefully at these 2 whole fractions. These 2 wholes. And I want you to tell me the fraction of the shaded and the unshaded for both. And I want you to make sure you come back, because when you come back, we will check our work together. Are you ready? Great. Okay, here you go. I'm sending you off to do your work. And make sure you come back and press play so we can check our work together. Okay? Bye, scholars. Have a good time. Remember what we learned about fractions and wholes. But make sure you come back because Miss Dennis is going to be here to show you the answer. Great. Okay, scholars, welcome back. Let's go and check our work together. So let's look at the first whole. How many parts make up the whole? Let's count. Ready? 1, 2, 3, 4, 5. So we know that the denominator is going to be 5 because 5 parts make up the whole. Now we're looking at shaded versus unshaded. Well, how many of these parts are shaded? 1. Excellent. So we know that 1/5 of the whole is shaded. So that means what is left that is unshaded? Well, there's 1, 2, 3, 4 parts that are unshaded. And so the unshaded fraction would be 4/5. How'd you do? Did you check your work? Okay, great. Now let's look at the next whole. Well, let's count to see how many parts make up the whole. There's 1, 2, 3, 4, 5, 6, 7 parts that make up the whole. And so I know that my denominator is going to be 7. So now let's check to see, well, how many of those parts are shaded? Well, if I look, there's 1 part of the whole that is shaded. And so my fraction of the shaded is 1/7. So if 1/7 is shaded, well, how much is not shaded? There's 1, 2, 3, 4, 5, 6 that are unshaded. And so that fraction is represented by 6/7 or 6/7. Okay? Great. How'd you do? Excellent job. I am so proud of you. Isn't fractions fun? So today we are going to conclude our lesson for today. And it's very important that you remember to use Zern and Reflex Math, because when you use these programs, it helps you become a better mathematician. So as we conclude our lesson for today, I'm so proud of you. We learned a new strategy about partitioning fractions, and I want you to continue practicing this at home and every day, because when you practice these things, it only makes us better mathematicians. Okay, scholars? So Miss Dennis is going to dance her way off, and I will see you tomorrow for another excellent day of Tic Tac Math and teaching and learning. I'll see you later. Bye.